You wake up given a number n and you're told a second number t. Your job is to find the smallest number that is greater than or equal to n, where if you multiply all of its digits together, that product comes out evenly, divisible by t. Any number you give me, I can solve in 9 steps or less. Hey, I'm Kai. Welcome back to Fun with Learning Technology, the channel where we take LeetCode problems apart until they stop being scary. Today's puzzle looks like it wants heavy math. It doesn't. Here's the setup in plain terms. You get a starting number, n, and a target, t. You need the smallest number greater than or equal to n, where multiplying all its digits together gives something divisible by t. In short, keep counting up from n until the digit product cooperates. Picture a bouncer at a club door, counting people in one at a time until the head count hits exactly the number the fire code allows. That's this exact pattern. Scan forward until one condition clicks true. It's the same trick behind generating the next valid license plate or throttling a counter. By the end of this video, you'll spot this pattern and solve it in seconds. Say n is 15 and t is 3. 15's digits are 1 and 5. 1 times 5 is 5 and 5 doesn't divide by 3. So we move to 16. 1 times 6 is 6 and 6 does divide by 3. 16 is our answer. Think of a number like a padlock with one dial per digit. We read each dial left to right, multiply what we see into a running total, and at the end, we check if that total divides evenly by t. That's all modulo does. It's just a remainder check. 4 small moves, nothing more. The obvious move is to just check n. Does its digit product divide by t? If not, check the next number, then the next. This feels almost too simple. And you might worry, for a bigger t, could this crawl on for a long time? Here's the trick. I call it the zero safety net. Look at any 10 numbers in a row, like 21 through 30. One of them always ends in 0. The moment the number ends in 0, its digit product is 0, because 0 times anything is 0. 0 is divisible by every single t from 1 to 10. So no matter how unlucky we get, we're guaranteed an answer within 10 steps. In short, the zero safety net caps our search before it ever gets slow. So the algorithm writes itself. Start at n, multiply its digits. If that product divides evenly by t, we are done. Return it. If not, move to the next number and repeat. Thanks to the zero safety net, this loop never runs more than 10 times. First, we compute the digit product. We turn n into text so we can walk through each character, convert it back to a number, and multiply it into our running product, which starts at 1. Once we have the product, we check it against t using modulo. If the remainder is 0, we found our answer and return n. If not, we bump n by 1 and the loop tries again. Here it is end to end, one loop, computing the digit product and checking it against t, moving forward until it clicks. Clean. Let's slow down on that multiply step using 16. Turning 16 into text gives us the characters 1 and 6. We start product at 1. After the first digit, product is 1 times 1, still 1. After the second digit, it's 1 times 6, which is 6. That 6 is what we test against t. Let's run the real code on 29 with t equal to 5. 29's digits multiply to 18. 18 mod 5 is 3, not 0, so we move on. 30's digits multiply to 0 because of that trailing 0. There's our zero safety net kicking in. 0 mod 5 is 0. We return 30. Quick challenge. Pause right here. What does this return for n equal to 7 and t equal to 9? Work through 7, 8, 9 yourself and drop your exact answer in the comments before I reveal it. 7's digit product is 7, no good. 8's is 8, still no. 9's digit product is 9 and 9 mod 9 is 0. We return 9. No need for the zero safety net this time, we got there directly. 3 real claps. Initialize product outside the while loop and it keeps growing across attempts instead of resetting. Start it at 0 instead of 1 and every product reads a 0, so everything looks divisible. I've done that myself, out of habit from summing instead of multiplying, and spent 10 confused minutes on it. Jump straight to n plus 1 and you'll miss cases where n itself is already the answer, like our very first example. Here's the one that gets people. Start your running product at 0 instead of 1, out of habit from summing instead of multiplying, and suddenly every single product is 0. Everything looks divisible by t, and you can't tell real answers from broken code. I've lost 10 confused minutes to exactly this. 2 smaller traps right along with it, forgetting to reset product inside the loop and jumping straight to n plus 1 instead of checking n itself first. Because of the zero safety net, this loop runs at most 10 times, and each check only looks at a couple of digits. That makes this big O of 1, constant time, no matter how big n or t get within these limits. The same loop handles every edge case without special casing anything. If n already works, like 10 with t equal to 2, we return it immediately. If t is 1, literally any digit product divides by it. And plenty of answers like our 9 example show up before we ever need a trailing 0. So here's the whole thing. Start at n, multiply its digits, check the remainder against t, and step forward until it clicks. The zero safety net guarantees you're done within 10 tries, so this stays big O of 1. Remember how this looked like it needed heavy math? It never did. The real takeaway, whenever your search space has a guaranteed reset value nearby, like a trailing 0, stop worrying about the worst case and just simulate forward. Stop worrying about the worst case and just simulate forward. Want to take this further? There's a part 2 of this problem where you're not given n at all. You have to build the smallest number from scratch using a totally different trick, factoring the target into digits 2 through 9. Keep shipping. See you tomorrow, small channel, so worrying about the worst case, and just simulate forward. Want to take this further? Quick quiz. Why do we never need to check more than 9 numbers past n? Pause it and think for a sec. Think about what happens to that last digit as you count up. Somewhere in the next 9 numbers, the last digit rose to 0, and a 0 digit makes the whole product 0, which is always divisible by t. Round 2. Say a candidate number contains a 0 digit, like 105. Does its digit product count as divisible by t? Take a guess. It's sneakier than it looks. Think about what 0 does to a product. Yes, always one 0 digit collapses the whole product to 0, and 0 is divisible by anything, so it's basically a free pass.